Hello everyone. Today we would like to demonstrate you graphene measurements by miniRaman spectrometer and miniRaman microscope. Graphene samples were kindly provided for us by company Danish Graphene and also the Technical University of Denmark. Let's try measurements by the spectrometer. Now our spectrometer has inside 660 nanometers laser, and it can operate in the range from 300 inverse centimeters up to 4000 inverse centimeters with average resolution across the spectrum between 7 to 8 inverse centimeters. And this way, let's say I'm turning on the laser light, yes, and I'm placing on top of the probe graphene sample. And you can see immediately how the spectra of graphene appear. First of all, to make you an overview, it's a graphene on a silicon substrate. That's why we see the peak of silicon and the overtone of the silicon. However, those other three peaks, they correspond to graphene. We can see here D band, 2D band, and G band. You can see it's a live spectrum. Let's say if I remove the sample, it disappears. If I place it here, if I place it here, you see it appears again. And if I move it, we can actually inspect the quality of graphene. You can see the peak ratio and the shape of the peaks. It differs depending where you locate the spot size. Currently, spot size on a sample is approximately 10 microns. However, if you would like to investigate graphene in way more accurate way in terms of resolution and depth confocality, then of course we would need to place it under the microscope. How we do it? That's a microscopy platform that fits miniRaman inside. And first of all, we should of course connect it to the microscope. So let me do that. Instead of connecting it to the miniRaman, I would place USB to the back of the spectrometer. Next step, I disconnect the probe and I put miniRaman inside the microscope. 1, 2, connect. Yes, it's connected and it's loading now. So we should wait until it's miniRaman inside blinking blue, which means it's ready to be connected, and it's yellow. We wait a second. Red, blue, good. And you hear it by the sound on PC. So now we can close the cover and here press connect. And it is connected. So let's say if I turn on the light, I would see a live spectrum with reference and main channels on the software. I would remove reference of polystyrene. We simply don't need it. And I also would probably include baseline correction based on, let's say, rolling circle, and we click apply. So we see it flat. So there is no extra luminescence and so on visible. Good. Now how about graphene? Let's say I place it inside, just like that. And this is a microscope objective 100x. Yes. And we already see a perfect spectrum of graphene on the screen. So let's a little bit investigate the situation. First of all, if I turn off the laser, we see the image, yes, and I can move a little bit here, and that's of course inhomogeneous graphene. We can see on the screen. We can a little bit fine-tune the light illumination on the sample, and then if I turn on the laser, this is the laser spot, yes. This is the laser spot. If I would, for example, remove the joystick here, then we can very nicely observe the spot where we shine and the spectrum of graphene. And you can see that right now 1 second is really overkilling for our spectrum. So I go to 100 milliseconds and we can in a very fast mode see as well 2D, 1D band and G band, including silicon peaks. And now we can also try to investigate the sample a little bit to get the power of microscopy. Let's say if I would do it like that. Yes, so there is our spot and we slowly move. Let's see what's happening. You see at some points, the spectrum of graphene is very changeable. Here you can see by the structure. Let's say we go to half a second size and we of course then can run Raman mapping. Oh, look, I found actually a very different spot size with a different graphene composition here. You can see by the peaks ratio. So if I move slightly, peak ratio is different. Yes, and I can go back to the same location. This way we can do graphene mapping in very fast mode. So basically 100 milliseconds is not a problem at all for such measurements. You can see that it's very fast and convenient way of doing that. That was our demonstration of capacities of our miniRaman spectrometer for quick quality control of graphene and similar 2D materials. And if you want advanced Raman mapping, you can just simply place spectrometer inside the microscope and do advanced Raman microscopy similar way. And it of course can be applied not just for 2D material, not just for graphene, but any kind of 2D materials and thin films and etc. Thanks a lot for your attention.